Hi everyone, welcome back to Pine Hollow Auto Diagnostics. As you can see, we're not in the Pine Hollow shop anymore. That's because over the summer, I, mostly for personal reasons, left the horse farm and my ex-wife Amanda and found a place with more garage space, and I met an amazing girl who actually wants to start a family. So we're doing that. We got plenty of cars to work on, so business is booming, like this 92 Alfa Romeo. That's going to be the Christmas special. 2009 Beached Whale Corvette. Hopefully we'll get that running today. But I just want to say thank you everyone for your support. I really don't like mixing personal life with business, but I know people would have questions if the videos just started, at another shop, and just a quick little explanation. So, by the way, I am going to be a dad early next year, so I'm super excited about that, and I'm sure you'll get to meet my girlfriend soon. She's a little camera shy at the moment, but very exciting things to come. So big changes in 2025, but really looking forward to the upcoming year, and we'll see you in 26. Hey everyone, welcome back to Pine Hollow Auto Diagnostics. It's the first video that we're filming from the new shop, and we already have a big waiting list of customers dropping off their vehicles, so the shop isn't quite all set up yet, but we have to get started and get these cars diagnosed. First one is a 2013 Ford Edge all the way from New York City, from Long Island. I think it took the guy 6 hours to get it here. It's his wife's car. She's refusing to drive it because he keeps leaving her stranded with a dead battery. So parasitic battery draw complaint. He did some preliminary diagnostics himself. Let's read the customer complaint and take it from there. Alright, here's the appointment form. Let's do a quick read through of the customer complaint. Problem child, my wife's 2014 Ford Edge, 3.5 liter, 124,000 miles. About a month ago the battery went dead. I tested it with a TOPDON battery tester and a pile battery tester. Both showed time to replace the battery. Okay, it was about 4 years old. Replaced it with a flat plate AGM, all was good for 2 weeks. Then it went dead again after it was parked for 4 hours. Interesting. I did a parasitic voltage loss. I made the connections, waited for an hour for the car to go to sleep. When I removed the cable from the battery, it took the 10 amp fuse in my meter. So big draw. And took out my TOPDON IR camera, looking over the car, found that one of the relays, number 66, was very hot. Right here. Relay powers several fuses. I disconnect the battery and then reconnect the battery, and the relay was off. When I turn the key on, the relay closes and stays on when the key is turned off. Interesting. I spoke to a local shop who I'm friendly with. They do most of my own work. Did not want to get involved with electrical problems. We spent about an hour going over wiring diagrams, showed the relays ground state controlled by the PCM. They talked me into ordering a PCM from FLAGSHIP ONE. Wrong. I know parts canon. I received the PCM today. Will not start because the keys need to be reprogrammed. I did check the relay. It's still staying on, so it looks like I wasted time and money. Would like you to have a look at it if you have time. Okay, excellent. So we have some direction. Let's do a pre-scan, all the codes in the car, and see what it does. Is something staying on when you turn the key off? Alright, so to save some time, did the code scan, and here are the codes. ABS has battery voltage, data received from ECM, PCM is invalid, missing communication with engine computer. Battery voltage again. BCM says missing communication with PCM. Battery voltage, run start control. That's interesting right there. Missing communication with steering column control module. GPS, HVAC. Again, fussing about PCM. Missing communication, blah blah blah. Battery voltage. So, okay, interesting code list. But the customer said that at some point he tried to start the car with this relay removed, and it probably set all kinds of codes. So I want to clear everything out start from scratch, start it up, shut it down, and measure the current, see what's staying on. Let's do that right now. Alright, so we're inside the car, 129,000 miles on this Ford Edge, and here are all the codes. So I'm just going to clear all DTCs right now. Battery voltage is good. I don't have a maintainer on it at the moment, but we'll put one on if we need to. Alright, good. So all codes are cleared. Shut the key off. Give it a few minutes to go to sleep. Right off the bat, you hear this little high-pitched whining sound, so something's still alive. That's the throttle body. And the relay that the customer was pulling is this one right here. He marked it. That is indeed the PCM relay. So let's start the car up. So it starts and runs fine. You can see that the traction control light is on for some reason. Let's do one more code scan. Check brake system. Okay. I'm just going to scan it for codes. See what's going on. Well, absolutely no trouble codes. Okay. So, just leave that for now. Let's shut it off. And we'll time it. So right now it's 10:10 a.m. I'm going to give it maybe 15 minutes while we do some research. We'll see if this humming sound goes away or not. And let's put an amp clamp on the battery cable right now, see what the amp draws at the moment. Alright, so let's use our amp clamp to see approximately what the current draws. It's supposedly pretty big, so this should pick something up. We'll start with zeroed. So around this one going to the fuse box. Maybe a couple of amps. Around this one, about 4 amps. Around this one, nothing on that one. So while the car is going to sleep, a neat test you can do with your scanner is just do a scan and see what's online. So, like the ABS, it's offline. That's good. Some things will be online, like the body control module. But I don't expect the PCM to be online, but I suspect that it will be. But, you know, newer modern cars, sometimes they keep the PCM alive for doing evap checks, this and that, so it's not necessarily a problem if it doesn't go to sleep right away. But and on Fords, it might take half an hour, 45 minutes. But I don't think the throttle body should be awake for, you know, doing an evap check. You can hear that buzzing, so that's not necessarily correct. PCM right there is alive. So is a lot of stuff on the medium speed can. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 modules that are online right now when they're not supposed to be. Initially, we had 16 modules, so 4 of them went to sleep, like, you know, ABS, parking assist, airbags, what is this, occupant classification system. But a lot of things are still online, so go figure. Like PCM, if we go in here, we'll probably be able to read live data when the car's supposed to be asleep. Yep. Here's some live data at the PCM with the key off. Everything's supposed to be off. Let's press the gas pedal, see if this thing's actually alive and responding. Yep, I can hear the throttle move. There's full pedal, 100%. So the PCM right now is fully awake. That's pretty crazy. Alright, it's been 40 minutes. I can still hear the throttle body. We're putting in about 9 amps from the battery charger, Tornado 90,000. Sure enough, you know, that agrees pretty well. So yeah, about a 10 amp parasitic drop because the engine computer is staying alive. What's the next step? Let's get a wiring diagram for the powers and grounds on this engine computer. See what turns it on. Is there a wake up line, ignition on, you know, signal from the key or wherever, and then we have to go to the PCM and check those lines. Something's keeping this computer awake. Alright, so from the OE diagrams on all data, this one page has all the powers and grounds for the PCM. So let's focus on this and check the powers and grounds with the key off. Let's go over these. So I wrote them down by pin number, wiring color, the function, and if it's fused or not. So let's start with pin 35. There's a PCM wake up line coming from the BCM. That's a power side switched transistor. That could cause the engine computer to wake up. Next, pin 42, yellow and orange wire, that's ignition positive. That's this one right here. Comes from fuse F90, hot in start or run. So we're going to check that one. Is this one hot with the key out? Then we have a constant battery power right here coming from a hot at all times fuse F86 7.5 amp. Then the PCM power relay, this is the one that's staying latched. The control pin is pin 38, and then the output is pin 67 and 68. And then we have our grounds right here. So let's do the easy checks first. I have the connector exposed, but I want to check if this fuse right here, F90 10 amp, is that hot right now. With the key out, it should not be hot. Okay, so we got a test light connected to battery ground. Finds a positive, is going to light up. Fuse 90 is right here. So by this relay, this one right here, it is not hot. So that's fine. So we can write here, you know, okay. But we didn't check at the PCM. However, I'm going to check it off. There's no way that wire is hot if the fuse isn't hot. Now let's check the PCM wake-up line, pin 35. So in the BCM, right now, you know, the key is out, but we're reading live data, and I actually found this PCM power control module wake-up output. It says inactive, so the BCM thinks that that wire is inactive. It's even measuring the current, vehicle battery current. It says minus 4 amps. So everything's off. The key's off, key is out. Everything looks great here. But let's find this wire, pin 35, at the PCM connector, probe it, and see if that's hot or not. Alright, so I got the violet and orange wire with a piercing probe on it. So we want to do all the checks with the vehicle as is in its alive state. If we unplug something, it'll change. So that's why we're poking a little hole. It's better than back probing PCM connectors 100%, and we'll seal that hole up once we're done. This is a nice dry area. I'm not worried about green crusties or anything. But we have no voltage on there. And with the test light connected to battery ground, again, make sure it works. That's not lighting up my test light, and it goes to 0.00 volts. If I let it go, it's 16 millivolts. So that's also good. So violet orange wire, 0 volts. Pin 42, 0 volts. We can find pin 42 and also probe it, but I'm sure it's going to be at 0 volts. So yellow orange wire. Let's just do that check to prove it 110%. All right. So here we have a perfect example of where numbers are more powerful than a test light. Usually for powers and grounds, test light, light or no light, you're good to go. In this case, on this wire right here, pin 42, the yellow-orange wire, we have 2.5 volts. How is that possible? 2.5 volts. That's a problem. Is that keeping this engine computer alive? If I take my test light to battery ground and touch that, let's look at the number. Look at that. It went to 88 millivolts. Everything shut off. And if I let my test light go, it comes right back on at 2.5 volts. So we have a soft floating voltage of 2.5 volts on that wire. And that's turning on this engine computer. Okay, now what's the next step? How do we find where this voltage is coming from? A couple different ways. I'll let you guys think about it and we'll be right back. Alright, did you guys think about it? 2.5 volts, where is it coming from? Is it coming from here? Is it coming from the PCM? What's the easiest and most non-intrusive way to start looking for this stray voltage? I'm going to pull fuse F90 10 amp and see what happens to this number. And see if our engine computer shuts off. Okay? So, that's going to be this 10 amp fuse. And I'm going to pull it. 0, computer shut off. So the voltage must be coming from this fuse box. Now let's get a probe and see if there's a voltage right here at this fuse. Alright, so now at the fuse box with fuse F90 pulled out, I'm measuring voltage on each one of those terminals. And one of those terminals is 2.8 volts. So that fits. The other terminal is 0 volts. That's the one going to the engine computer. So we're dealing with a problem right there. So on your diagram, the issue is upstream of the fuse 2.8 volts. This is bad. This is the whole entire reason this engine computer is staying on. Okay, now where does this come from and how does it become hot and start or run? So we need to look up power distribution diagrams now and see why we have 2.8 volts on here. Something like that, it's when the voltage is in between. It could be bridging between contacts, little green crusties somewhere in a connector. You know, that's not a normal voltage. It's not 0 or 12. It's somewhere in between, and it's just floating. You know, with the test light, you can pull it down easily. I'll show you guys one more time. 2.8 volts. I pull it down with the test light. It goes to 88 millivolts. Obviously, it doesn't light anything. So that's a soft, floating voltage. And for the PCM, that means turn on. Apparently, the threshold is below 2.5 volts. So, are there green crusties in this fuse box, or is the problem somewhere upstream? I don't know how the ignition key's tied into this. We have to do some more research online. Alright, so power distribution. Here's our fuse 90, 10 amp, going to the PCM pin 42. Where does that fuse get its power feed? The run start relay. So I assume this whole tree is at 2.5 volts right now. Fuse 89, 90, 92, 93, 94. That whole row should be at 2.5 volts. Let's verify that and then find the run start relay, which lives right next to the PCM relay. If that whole row is at 2.5 volts, we can pull the run start relay out and see if that voltage drops off. Is it backfeeding through one of these fuses? It could be. Or is it coming from the relay? So we have to disconnect things and see if that voltage goes away or if it stays. Alright, so according to the diagram, all these fuses, 89, 90, 91, 92, 93, should be on the same relay, so I assume all these pins are going to be at the exact same voltage. Yep, 2.8 there. Next one, 2.8. Next one, 2.8. 2.8, and the last fuse in the row, 2.8 volts. Here's the run start relay. Let's pull that out. Without breaking it. There we go, it's coming out. And I'll keep my meter in one of these slots. So 2.8 volts. As soon as I pull that run start relay out, the voltage did not change as expected. I didn't expect the relay to be halfway stuck on. So now, is the voltage backfeeding on one of these two fuses? Well, let's pull those out. Let's start with this 10 amp. Our voltage increased a little bit because there's less load on that tree now. Let's put that one back in and pull the 5 amp out. Voltage is still there. Run start relay is out. So are we done? Is there an internal problem in this fuse box? Yep, sure. That's exactly what the problem is, because somehow voltage is getting on the circuit from, well, let's see, we have 14 volts on there, and on this pin we have the 2.8 volts. So this is the load side pin that feeds all these fuses. They're all at 2.8 volts. So somehow the voltage is bleeding over to this pin from some circuit inside the fuse box. Alright, well, this fuse box, I got it up. It looks like it's not a smart fuse box. There's no microprocessors in here. But the bad news is it's all integrated, meaning you can't take it apart and see where the green crusties are. See, there's our yellow and orange wire right there going to the PCM, but that whole row of fuses is being held at 2.5 volts by voltage bleed that comes from somewhere, and you can't take this thing further apart, unfortunately, to see why that pin is at 2.5 volts. That's a bummer. So are we calling this fuse box? Absolutely. There's no other explanation for this issue. If this row coming from that relay is at 2.5 volts and it's not backfeeding through any of the other fuses, then we're done. It's an internal problem in the fuse box. So what we could do, we can measure the voltage right now. I have it disconnected from the main battery terminal, so the whole fuse box right now is not powered up. But where's that voltage coming from? You can't say. It's a little crusty in this area. This area looks okay, but internally that corrosion could have made it to this circuit, and it's just a soft bridge. I'm sure it's a little tiny problem that could be corrected by cleaning or disassembly, but you can't disassemble this thing. It's frustrating. I want to get this car back on the road. No parts required, because where are you going to get a fuse box, and how do you replace it? I mean, does it just plug in, or is it part of the wiring harness? I don't see any big bulk connectors. It has to be part of the entire wiring harness for this vehicle. This is insane. Could we somehow modify it so it works? I mean, the run start relay, the control circuit's fine. when we wire an external relay, but we have to take these fuses off of this box because this box is shorting that entire tree to 2.5 volts. If you power up this box, all the fuses here are going to stay alive. Obviously that's not good, so that would take some work. You would have to disconnect at least these populated circuits, these 3 fuses, and put them on an external relay. You know, snip some wires here and time to a separate little external fuse box perhaps. But this really sucks. Well, this is a bit surprising. The fuse box is disconnected from the main power, but guess what? We still have 2.7 volts on that tree. What does that mean? Well, so this pin, I'm sure is going to be at 0 volts now, since, you know, 0.5 volt. Okay, what about right here? 0.5 volt. So something's backfeeding a little bit, but that pin is at 2.7 volts. So where is that coming from? It could be coming from anywhere. Anywhere. Let's take another look at the power distribution diagram and see if there's an explanation for this.